Software process. Advances in computer science, especially non-numerical computation and relational database systems in the 1960s, led to a rapid expansion of computer applications in the business sector. The ad hoc development approaches that existed then could not satisfy the needs of business organizations. The notion of a software development process or software process was introduced. It is defined as follows. A software process is a series of phases of activities performed to construct a software system. Each phase produces some artifacts that are the input to other phases. Each phase has a set of entrance criteria and a set of exit criteria. For example, the waterfall process exhibits a straight sequence of development activities that begin with requirements analysis, followed by software design, implementation, testing, deployment, and maintenance. It is called a waterfall process because its straight sequence of activities resembles a waterfall when the activities are shown vertically one after another. The requirements phase produces the requirements specification, the design phase produces the design, and so on. Frequently, the entrance criteria specify the software artifacts that must be available. For example, the entrance criteria for the software design phase are that the requirements specification must have been produced and reviewed. The exit criteria specify the software artifacts that must be produced. For example, the exit criteria for software design are that the architectural design and high-level design must have been produced and reviewed. The waterfall process has been used since the 1970s. And some organizations still use it. The straight sequence of phases of the waterfall process simplifies project planning, project scheduling, and project status reporting. Because of these, it is deemed a predictable process. Moreover, the straight sequence of functional activities allows function-oriented project organization. In such an organization, the functional teams are specialized in different functional areas such as requirements analysis, design, implementation, and testing. Projects are carried out by the functional teams in the pipeline manner. Finally, the waterfall process is appropriate for developing large, complex, long-lasting, embedded systems. Examples include mail sorting and routing systems, process control systems, and many other types of computerized equipment. Price cause contraceptive bio Prototype and Such systems need to respond to numerous hardware-generated events, process huge amounts of incoming data, and control the behaviors of hardware devices. Usually, The capabilities or requirements of such systems are jointly defined by the equipment manufacturer and the customer. In many cases, the system to be developed is merely a major enhancement of the functionality, performance, and security of an existing system. The vendor has experience and good knowledge of the application and what the customer wants. Hence, major changes to the requirements are rare. Once the purchase order is issued, the customer does not have access to the equipment until the acceptance testing stage, although the customer participates in reviews and prototype demonstrations. The phased approach allows each phase to be performed rigorously to ensure that the system runs reliably and satisfies performance and timing constraints. The waterfall process has a number of drawbacks. First, the strict sequence of phases and related milestones makes it difficult to respond to requirements change. This is because requirements change requires considerable rework. Unfortunately, requirements change is the way of life due to business competition, new regulations or standards, or advances in technology. For many applications, the long development duration is unacceptable because the requirements were identified long ago and business needs have changed dramatically. In addition, the users cannot experiment with the system to provide feedback until it is released. Experiences show that early user feedback helps in detecting misconception of business needs and problems in user interface design. Finally, the customer cannot reap the benefits of the new system during the long development period. Recent trends in software engineering focus on agile processes, design patterns, and test-driven development. Agile processes stress collaboration, adaptability, rapid deployment of small software increments, and close cooperation with customers and users. Design patterns provide proven solutions to common design challenges, fostering software reuse and improving team communication. By encoding design principles, patterns also help less experienced engineers produce high-quality software. TID promotes creating test scripts before coding, ensuring that software is testable and allowing for frequent, immediate testing. To understand the importance of processes and methodologies, consider the analogy of building an amusement park. The development process for a theme park includes various phases such as planning, analysis, design, financing, construction, and equipment installation. Each phase has specific activities such as feasibility studies during planning or site investigation, and park layout design during analysis and design that must be performed to complete the project. However, simply knowing the overall process is not enough. The team must also understand how to execute each activity, much like a software team would need a methodology to guide them through coding, testing, and deployment. In the case of an amusement park, the conventional approach is to finalize the master design early on. Once completed, it becomes difficult to modify without incurring significant costs. Similarly, in traditional software development, altering a finalized design late in the process can be expensive. Agile processes aim to solve this problem by allowing the project requirements to evolve throughout the development cycle. For example, a theme park can be developed incrementally, with different clusters of attractions built and deployed one at a time. This approach enables early feedback, allowing changes to be made to the requirements, budget, and schedule before the entire park is completed. The same applies to software development. Agile methodologies facilitate rapid deployment of small increments, allowing stakeholders to provide input and enabling the system to evolve as needed. This flexibility makes agile processes ideal for adapting to changing conditions. By focusing on teamwork, development, and continuous feedback, agile methodologies enable projects to deliver results earlier, make adjustments more easily, and maintain high quality throughout the development process.